This is the video for homework number 2, sections 2.1 through 2.4, problem number 1, where we're looking at determining the magnitude of a resultant force and its direction. So we're going to take the two forces that we're showing now and break them into their x and y components. You could also use Cartesian vector notation, but for this one I'm just going to break them into their x and y components. So if I draw my first force as my x and y, when I look at my force, it is going to be at 45 degrees, and its value is 200 newtons. This is 45 degrees. So when I break this one up into its components, I'm going to first do the x component, which is going to be along the bottom here, and it's going to the right, which is positive. And then I'm going to resolve the y component, which is going up. So I'm going to assume to the right is positive. For the x component, it is positive because it's going to the right. It is 200 adjacent to the 45 degrees, so it's cosine, which is going to give me 141.421 newtons. And then my y component, it is going up, so it is also going to be positive, because I said up was positive. It's going to be 200, and this time it's the opposite side from the angle, so it's going to be the sine of 45 degrees, which also equals 141.421 newtons. You have to be careful with this second force because it kind of shows you in a direction, makes it a little confusing. But actually, if I'm going to draw force 2, I'm going to draw my axis like this. This is my x, this is my y, so we're actually in quadrant 2 for F2 because it's actually going this way. And they tell us that F2 is equal to 150 newtons. And since I moved the force this way. That means this angle is going to be the 30 degrees because the angle was down here. So this is the same angle. So to break this one into its components, first I'm going to do the x components. Assume to the right is positive. F2 of x, so it's negative because it's to the left. 150 times the cosine of 30 degrees, which equals negative 129.904 newtons. And my y component is going up, so it is positive, and it is going to be 150 times the sine of 30 degrees, which equals 75 newtons. Now to find my resultant force in the x direction, I am going to add the two x components. So I've got 141.421 plus, well, it's minus because it's negative 129.904, which equals 11.517 newtons. So it's still positive. And then, assuming up is positive, our resultant force in the y direction, we're going to add those two together also. So we've got 141.421 plus 75, which equals 216.421 newtons. So when I look at that, I've got a positive x and a positive y. So when I draw my little graph to see where my resultant force is, they're both positive. So I know the point's going to be somewhere in the first quadrant. So this is what it's going to look like. That's going to be my F of R. which means my theta is going to be from the positive x-axis. So to find the magnitude, I'm going to take the square root of the x squared plus the y squared, 11.517 squared plus 216.421 squared. Take the square root of that, which is going to give me FR equals 216.727 newtons. So that's part of my answer. Remember, we're looking at a vector, so we have a magnitude and a direction. We can't just give a magnitude. We have to tell them which direction it's going. So in this case, my tangent of theta is going to be the y component over the x component. 11.517. So theta equals 86.954 degrees, and that is measured counterclockwise from the positive x-axis, and that is our answers. Make sure you always box your answer.